story with you guys. After last Thursday's webinar, I spent some time with Dale, and there was a very special comment he made. He said, "Howard, I didn't want to answer all your questions because I may contradict what you were saying." And I thought, oh my goodness, where have I gone wrong? What did I do wrong, or what did I say wrong? And Dale was very kind to share his presentation with me, and I was able to spend some time. I really enjoyed it, spending time working through his what he was suggesting in this Midcot framework. But I really enjoyed it, Dale. Thank you. Thank you for what you've been doing. And I really encourage everyone to ask the questions, because there's some quite important things, like I have been talking about LLM as a judge. And Dale talks about AI as an auditor. And I thought this was quite a nice idea until I read one of Dale's things. He said, no, we don't use any of this. So I really appreciate that, and it's nice to learn and understand exactly. Sometimes we just follow what people are saying. It makes some good sense, but there are some challenges with it. So I know Dan Myers is on here, and of course I did a comparison with what Dale was doing with Dan Myers. So really nice. I think there's lots to talk about. And over to you, Dale. Thank you very much for the sharing.
Thank you. Let me see if I can share my screen. Okay. Can everybody see the screen?
Yes, we can.
And Debbie, if you can kind of watch the chat, because I get focused on my charts and I keep forgetting to look at
Dale,
the chat.
I'll do that, Dale. I'll do that, and
Okay.
I'll make sure that.
But I'll be him.
Yeah.
And I'm going to put a caveat before we get started there, because the work that I do kind of it's an umbrella, holistic approach to governance of large language models and AI models. And some of this overlaps with work that Howard does, and I've looked a little bit at what Dan has done with conformed dimensions. Did I say that correct, Dan? And Mark, I think you've done some work in this area as well. So I kind of anticipate some pretty good discussions coming from this. So one of the things I want to highlight first is that what started me down this path, I think the context is important. When I first started my PhD, I was looking at how I could use AI to enhance the decision support templates. And so you started looking at the reliability of the AI models. One of the things that came to the forefront very quickly was the apophagy of the AI models. Everybody recognizes that AI models are not really, 100% accurate, and we picking at different parts of it, trying to figure out the puzzle. But to me, if you got that apogee going on, where does that land us? And so I did modeled a simulator on LLM apophagy. And what surprised me, and I'll show you the simulation later, was that once this model starts to consume itself and starts to decline, even if you find some point that you recognize that and you try to mitigate it, you'll never reverse it. You may cause it to plateau, but that model decay is going to continue. And all of this was based on most of the measurements that's going on is always after the fact. And they're always looking at some static point within the models. And so to me, I thought, well, if you're going to solve this, you're going to have to go back upstream and start at the top. And then you have to figure out where's this going. So the first thing I did is that I tried to map the large language model AI lifecycle, the data lifecycle. And once I did that, I tried to identify where all the touch points were where bias, misinformation, and error could be propagated or amplified. Once I could identify those touch points, then it was a matter of trying to determine how can I establish metrics where I can measure at that touch point, how is it impacting the bias, misinformation, or error? Everybody follow me so far?
Yeah.
So from that, it broke down, and I have 3 different layers. You've got the micro layer, which is where the human interface with the model. And we all probably familiar with all these dynamics that go on there, how you prompt the machine, cognitive bias, and so forth and so forth. Well, when that context window, as you're engaging with that model, you're getting feedback loops of your either confirmation bias as you're proceeding with that conversation, and it's feeding back into the model, which is causing a drift. And then depending on how the model's designed, that can feed back into the model, or if you're getting RAG pulled into the conversation, you've got another loop, and then your context window reaches into what I call the meso layer, which is actually the architectural layer. And then the macro layer is that once you get the output, people are putting this in research papers, you're doing social media posts and things of that nature. And a large part of this corporate information is being retrained into the model. And so then it creates this never-ending cycle that you're constantly feeding it more and more garbage, and the model is decaying. And so ultimately you start getting amplification bias, reduced output diversity, and misinformation reinforcement. So as you'll see these metrics here, I tried to identify metrics where I can measure at different points. Okay, so I'm looking at the model as a whole. How can we approach this from a governance standpoint where I can go back upstream and we can mitigate some of this effect before it gets to the output, right? So you go ahead.
Sorry, Dale. There's a question from Dan, and he's in the previous slide, and he's asking, don't we have the reinforcement in the human sphere as well with groupthink?
Yeah, yes. So Howard, you don't have to interject for me every single. I mean, I have a million questions for Dale later in the thing. So give me the first 2/3 on chat, and then the last third of Dale's spiel. Then we'll get into it. Is that okay? Otherwise, he won't make it through anywhere.
All right. Okay.
But well, Dale, I was just
hopefully I'll get through this.
Exactly. I was high-fiving you on what you were saying. I was just saying that in the human world, I think we call it groupthink, where, in order to like what you had said with Howard was you didn't really want to throw everyone off, so you didn't want to contradict him. But I think we start saying, oh, I don't want to offend somebody, and instead we don't have the most robust outcomes, and the models sort of are doing that too, is what you're observing. Is that true?
Right. Correct.
Yeah.
Okay. So basically, when we start looking at the data quality, the gap in AI systems, existing governance, your standards tell you what to measure, but what we don't have is a way to measure. And so the ALOGF overall framework, which Midcot is part of that, start giving us a framework. How can we measure all of this at these different points? Okay. And from a structured data, the data analysts and the data architects, you guys got this worked out pretty much. You've been hacking away at that for many years, and it works pretty well. What we don't have is a solid foundation for quantifying and measuring unstructured data. Okay, how do we quantify that and measure that quality? So here's the full framework that I'm working under, and I have some core metrics that we deal with. And if Howard allowed me to come back again, one of the things I'll focus on is the bias amplification rate, because bias is it's an animal all of its own. I mean, you've got different types of bias, and for the most part, bias is very subjective. And they use the normative human assessment on bias. I've developed a model where I can use AI augmentation on bar, and I have a system called NOBI that actually can assess bias within the corpora or in the output. It actually quantifies that bias data. And then that can feed back into the bias amplification rate, which what it does, bar measures change in the bias. So if you have to, most of all the bias measurements now are all static, 1 point in time. And it'll tell you, does bias exist, but it doesn't quantify it, nor does it tell you, is it going up or down as your model is cycling, all right? So what we're going to focus on today is the Midcot. Midcot goes back to the very beginning, and it focuses on the corpus, your training corpus, because garbage in, garbage out, right? But there's a lot of work going on where people are trying to assess the methodologies for data cleaning, data processing, pre-processing, things of that nature. But the real problem comes in was when we start retraining. Or when we retrain, is the new data training corpus better than the previous one, or did we have a decay? Goes back to that model Apophagy. Is the new training model degraded from against the first one? So this is what we're going to focus on today, and I think hopefully everybody understands where I'm coming from, taking it from a bigger picture down to what this focus is. Okay. All right. So bridging data quality frameworks and AI governance. From accuracy, the record traditional scope is record level correctness. What my frameworks focus on is distributional accuracy over time. We're measuring as this model's dynamics is processing. And so we can check if there's an increase or decrease, completeness, consistency, timeliness, and integrity. Okay. So one of the key fundamentals of the work that I'm doing is everything has to be aligned with the standards and guidelines. If you don't, we can create all kinds of pretty things that work out here, but if they don't align with the standards and the guidelines from a governance standpoint, they're worthless. Okay. So this is basically the ecosystem that I was working under when I developed what I'm at now. I'm continuing to work on this, and I think, Howard, you've agreed to kind of help continue some of this, and Dr. Talbot is going to be working with me as well. Okay. All right. So I think you're familiar with this, where I started sitting in on all these sessions, and I'm seeing where you guys are talking, and this is a real powerful chart. I assume you developed this chart, Howard. That's where I saw it. Yeah. I didn't see it anywhere else.
Yeah.
Okay. So when we're looking at this, the data funnel, and we're doing the pre-processing, the key is how can we measure this? Okay. And you've got to set a baseline. Then we have to be able to monitor it, detect if it's drifting, diagnose it, what the root problem is, and then remediate. So in terms of monitoring, what I did is I reverted back to my old training in Six Sigma and used statistical process control. So if I can measure it, then I can set a statistical process control limits, and then depending on where it's floating between those upper and lower control limits, it'll set off it'll detect a deviation and send off an alert. Now, one of the things about statistical process controls, and I think Howard, I think you mentioned this to me the other day when we were talking about scalability.
Yeah.
these statistical process controls, you can set these limits relative to the type of business or industry you're in. Because if you got somebody over here is making rubber ducks, their risk tolerance may be here. But if I'm in healthcare industry or medical instrumentation or medicines, pharmaceuticals, my risk tolerance is very low. So your statistical process control process, you can calculate that. And this goes back to your governance. When you have to answer for governance, it allows you to justify, why did I set those control limits? And you can have full disclosure. My risk tolerance is this, or this one's risk tolerance is that. And this comes important when we start looking at the cost benefit analysis on the model here in a few minutes. Okay.
So Dale, look, just a question from my side
Yes.
on that SPC. Of course, we always see SPC as that ability to measure the quality expectation over time. And of course, there's the upper control and the lower control, but it's about where it's trending to, what direction is the quality going in. Now, previously you had something on accuracy, and then you said the traditional one looks at a record level and the other one looks at it over time, or the drift over time. Isn't it like with lots of our different quality things, we have a quality which is a snapshot expectation of the data at that time, but then if we use SPC, we're talking about the analysis of that over time. So just to understand that difference.
If I understood your question correct, the system does it's active monitoring. And so as it's actively monitoring, you're getting a feedback. You'll actually have a control panel, yes, or a dashboard, and you can see the movement, and you start seeing that trend line. The model itself, as you start approaching that upper or lower control limit, it might send you as a caution. It says, hey, look, you got a trend line that's moving in this direction.
Right.
You might want to keep an eye on it. The idea is you really don't want it to get out of control before you have a catastrophic, failure and having to stop what's going on. This is kind of the process flow chart. If you're interested, you said you're going to share this video later, and everybody can kind of study this. Yes. But basically, you start having your different aspects of the model that's controlling different elements, and I'll discuss this in the model when I do the demo later. Okay. So basically what you got is you got a baseline that's your stable baseline. You have warnings if you start trending in a certain direction. You've got it'll trigger a breach alert if you exceed that, and then you need to look at recovery or remediation. Now, the significance of this is with traditional models, it's usually not until somewhere down the road that we find we've got a breach and got a real problem. But by then, it's done compounded itself through the system that our training corpora may be fully contaminated or reached a point of quality and reliability that it's basically worthless. And how do we remediate that? It's not easy to go back and clean up a training corpora. You almost have to replace it. Okay. Mm-hmm. So if we can identify when we're starting to drift, then we can take action before it becomes a problem. Everybody follow me so far?
Yes.
Okay.
I think that's the big thing about SPC, isn't it, Dale? It's a case of it's proactive warning. It's telling you that a problem is going to happen before it hits or exceeds the breach, upper or lower. It's giving you consecutive points that are headed towards it.
Correct. And then some of this, these upper and control limits, like I said, you set those for your relative industry and your risk tolerance. And the reason being that there's a cost. One of the aspects is that when we deal with the the training corpora. I have what they call the axiom of governance. When we start talking about quality and integrity, you'll never get 100% pure, unbiased, misinformation-free or error-free data. It's just the nature of the universe of data. There's a mixture, and it'll never be 100%. But the closer we try to approach that 100%, the more it costs us to achieve that. And this shows, I apologize, I don't know where this chart, I got it off of LinkedIn at some point, I don't know, months ago. And where I got it from, they didn't identify the source of the chart. So I apologize, whoever created this, I'm borrowing it. But basically, companies that are trying to deploy large language models or AI into their workflows, they run into what we call the AI agent paradox. It's easy, within a couple of weeks, you can deploy a model that's 70% accurate. But is 70% accurate acceptable? Okay, is that better than human processing? I don't know, but you start running into an exponential cost factor. The more you try to approach the 100%, you start getting into a significant investment of time, money, and resources to achieve that. All right. So at some point, what we need to do is we need to have a point of equilibrium. Anybody knows economics, when we have a cost benefit equilibrium. So we apply the same things. So this is another aspect of the Midcot. It helps us process this cost benefit analysis, because depending on where our upper upper control limits, here's our lower control limit here, and your upper control limit here, or your target, and here's your upper control limit. So depending on what your acceptable risk tolerance is, we have optimum return on investment. How much are we willing to invest to achieve that next unit of increase in quality and integrity? So So this tells us what changes. The data quality assessment becomes continuous and not periodic. It controls its control limits replace static thresholds. Behavioral entropy joins traditional data quality dimensions. Corpus provenance becomes a governance requirement, and retraining decisions become audible governance actions. These are the things that stay the same. You still got your core data quality dimensions, metadata governance.
No, I was just saying that I was going to take that second to interject how valuable it is, and I didn't know that basically you have to scrap the model, at some point, and so I think one of the other things, and I don't think you touch on it here, but one of the other things that kind of concern me is we have financial data quality services, and you pay for them to scrub your data. But one thing I've noticed, they don't usually have a feedback mechanism where you're telling them what they got wrong, because the financial institutions try to use that as a competitive advantage by saying that they have better quality than their competitors, so they don't tell the service provider what's going wrong. And I think that we see that with our Claude or whatever it is. The large corporations are making deals to not allow Claude or Anthropic or whoever to train their models on the use of corporate data because it's sensitive, which makes sense from their perspective. But the model keeps deteriorating if it doesn't have that kind of training to keep it up, especially, as you're pointing out, variant data, meaning data that doesn't fit the model. So, that doesn't reinforce the model. And so, yeah, anyway, I appreciate what you're saying. Thanks.
This brings up a very important point. and throughout my research, one of the things that it comes out, and you can do your own independent research on what I'm about to say to verify it. But one of the major problems with corporate failure in their attempts to deploy AI, you have people like in finance, okay? And I used, years ago in my misguided youth, I was a stockbroker with Merrill Lynch. But in my master's degree, MBA is finance and accounting. So speaking from a little bit from experience here and working with these people, what happens is you get an organization like finance and they want to employ AI. They might understand finance, but they don't understand the AI models. And they don't know how to mesh the two. There's an assumption that the AI model is correct. And we all know that that's not the case. The AI model makes mistakes, and it's only as good as what you train it on, or how you set up the model, the use, your integration, deployment. So this is one of the big gaps in industry, I think, is causing a lot of the failure of the model, their deployment, is that you've got people over here that are familiar with their topic or subject, but they're not familiar with enough with the AI model to make them integrate. Am I making sense on that? And yeah, you don't want to share your corporate information with somebody else, which you can still create your own organic large language model and have it supplemented by, API model. But you've got to know what you're doing if you're going to design that. So what I'm proposing here with the Midcot and ALOGF framework is we have a way to measure these models. If you're going to design it, fine, let's design it. Now we can test it and see, is that quality and integrity there, or what's our baseline? And now we can monitor it and see if it's declining over time. Now they don't have a way to measure it. They don't know what they're starting with, and they don't know what they're ending with. So like the story of Christopher Columbus, he set out not knowing where he was going. He got there, he didn't know where he was. And when he got back home, he didn't know where he'd been. And that's what's happening a lot in reality. Okay. All right. So this is a chart that basically shows what are some of the...
Sorry, Dale, you're not sharing your screen. We're seeing the team screen at the moment.
I'm sorry. Am I not sharing my screen? How about now?
Now we can see it.
I'm sorry. So what this table shows us is some of the data quality and the data integrity features and benefits and cost efficiency of deploying this methodology. Okay. So I broke it down into data quality, and then you got the cost benefit optimization engine. So I'm going to stop sharing that, and let me move this over here. And let me share again. Let me move that out. All right, can you see this model?
Yes.
All right, so this is the Autophagy model. So what I did is when I was trying to figure this system out, and I showed you the chart where I mapped the entire life cycle, I started putting in, all right, here's the different parameters that we can adjust. And basically what it shows us is what is the decay rate in the models. So in this particular case, and we can change this, we're looking at 20 generations cycles, retraining cycles, retraining on a quarterly basis. And when we set everything else, what we show is that this model starts to decay, and by somewhere around year 4.5, we start getting to zero. If you start looking at the decay rate, from a governance standpoint, declines pretty quickly. If we try to do some type of mitigation, it slows the decay, but it doesn't reverse it. If I go in and I say, all right, well, what if we retrain on an annual basis? Well, the decay rate is not quite as fast. You notice here, what, 15, almost 20 years. But can we afford to let that training corpus sit there for a year before we retrain it? You know, how fast data's training. So the more frequently we retrain the model, you see here, if I change it to monthly retraining cycles, we start dropping off to 0 by year 1.5. But nowhere, when I tried to run this simulation, nowhere did it reverse itself. All we can do is just taking what we're given, we can slow that decay rate. The other thing we want to look at is your bias providence. If there's no governance, the bias increases to almost 100%. This is going up, but the intervention, we can improve the bias through intervention. Okay. The provenance integrity improves, but it doesn't reverse itself. There's your contamination dynamics. Here's your statistical process control monitor. And I'm trying to set this up on my website so you can go in and play with it and look at it. But the bottom line is, when I analyze the autophagy of the models, you can slow the decay, but you're not going to reverse it. So the only way that you're going to affect the quality and integrity of the database, you got to start upstream. You know, which end of the hose do you work with? And we got to go up to the top, you know, the training corpus, and start working from there to and monitor that to mitigate this autophagy. Does that make sense?
Yeah.
All right. All right. So can you see this? Did I switch?
Yes.
All right. So this is the Midcot. This is the demo model. So basically, it gives you an overview of what's happening with the model. Let me clear this. Okay. We can look at the probes. Now, one of the things with Midcot, we have 12 different probes. So I think one of the questions was the deterministic aspect of the Midcot. I looked at two different approaches. I explored them. One of them was doing an AI augmented model to help process this. But then what I started running into was that you got the fox watching the hen house. You got AI monitoring AI, and if the model is decaying, it's just going to continue to decay because it doesn't have a pure baseline to work with. What the probes do, you have a clear baseline, and then you can, using the probe to feature mapping process, you can actually stress test the model to see, are we seeing any drift in that training corpus? And so if you start seeing drift in any of these areas, and you'll start seeing here's your probe interventions. So you can monitor this on a continuing basis and look at all these different categories, aspects of the Midcot monitoring to see what's going on inside the model. Okay, it's almost like a doctor. You got different symptoms, right? Well, the symptoms don't tell you exactly what it is, but it's a culmination of the symptoms that tell you where to start looking deeper. And this is where you guys, is from the data analysts and data architecture, start digging deeper into this. This just highlights, hey, look, we got a problem, and here's where the problem may lie. Now it's up to somebody with a lot more brains than I got to dig into this, Howard?
Yeah.
Okay. So then we can start seeing where we've got drift. And it shows you where you got, if it's running okay or you got a breach. And it identifies which one of these probes is breaching. Now the cost benefit, the analysis here, what it does is starts giving you an assessment. I think I used $120 per unit. I just signed a number. So for every unit increase in your data quality or data integrity, it's going to cost you X amount of money. So if you've got a problem and you're monitoring this, it's going to kind of give you an idea of what do you need, what's it going to cost you to mitigate this and get you back on track. And so you can budget that, or you may roll it back. You know, that's a human decision. But this helps you take that measurement of saying, well, here's where we're at. We're drifting here. What do we need to focus on to get us back on track? And how much is it going to cost us to do that? In most cases, how many of you have worked with some of these AI deployment, and there's how much is it going to cost? And there's always this nebulous, well, I don't know. So this helps us put a number to a mitigation. And then you got a governance. The third part of this is the governance ledger. It tracks everything that goes on. It tracks when you got alert. It tracks what you're doing for your mitigation and so forth. So overall, this is a governance tool to help you monitor, measure and monitor and mitigate some of the things. Now, it doesn't get down into the weeds in terms of the mitigation of each one of these elements. It just gives you ability to monitor and identify when you're exceeding these limits. Now, I think, Dan, you'd asked about the conformed dimensions, and I think that's where your research is. And so we're conformed dimensions. I'll get tongue-tied. You want to explain what conformed dimensions are?
Well, I think I think maybe even Howard is better at that because he's a third party looking at it from a different perspective. And I thought he used an AI. I think Howard correctly. He used an AI, chat tool to compare the Midcot with the Midcot with the conformed dimensions. I actually, there's inside of the dimensions of data quality under consistency, the dimension of consistency, I call out temporal consistency. So I would completely agree with you that when you add the time aspects to all of the dimensions and underlying metrics of data quality, you have to look at it from an ongoing perspective. So I completely agree with you. I don't know that that's exactly new with Midcot, but it's absolutely necessary to be looking at data quality over time, right? Your time series rather than at a point in time. What I really liked is that I mean, when I developed the conformed dimensions, it was an observation. It was actually a meta-analysis of other people's dimensions of data quality to say, how would I govern? How would I try to bring that together into a single model? And I understand what you mean when you say we should all stick with the standards out there. And then you had your wheel of all the different, governing bodies of different things. The problem is the standards don't always agree. So what I tried to do I took like the ISO standard. So I don't have a lot of academic. I'm not a PhD, right? Like you, I'm more of a practitioner. So, but I did write a paper with Brian Blake, who was in your PhD program there at Little Rock. And one of the things that kind of like, we were looking at was also with the ISO dimensions, they're specific to the physical nature of the data, meaning at a physical instance. And so they deal with kind of portability and things like that, which to me don't make as much sense when data is so portable now. We don't look at the physical aspect. So I descope that out of the conformed dimensions. And so I think the problem is that everybody's model is kind of fit for purpose, fit for what they're trying to do.
Yeah.
And even though I tried to be unbiased and I said only unbiased metrics should be allowed in the conformed dimensions, I do have a scope. And no matter what you do in life, I guess you have to pick a scope, right? And so I think if people are saying, doing the pros and cons of the two, like if Howard was as a third party, Howard was like comparing the two, I think you have to look at what's the purpose of the two. Like conformed dimensions never imagined an AI world, right? I mean, this was 10 years ago.
Yeah.
When, before that came along.
So I think the two complement each other.
I suppose the highlight, Dan, of what you're saying is, and I remember you talking about this, is where you saw all the different people with different sort of definitions and different groupings and things like that. And what you were trying to bring it together, create a conformed definition of this, and then also to try to standardize our terminology in terms of how do we describe issues around quality, if I'm correct there, Dan.
Yeah, and I think that's absolutely critical for success in what Dale's talking about. Dale had said there will be thresholds that are different depending on the industry. And I completely agree. At the beginning of my journey, people told me the conformed dimensions is impossible. They said, you'll never have conformed dimensions. They said every industry, like medical healthcare, will have a different set of dimensions of data quality. And I said, I don't know that I agree with that, because data is data. We're talking about the quality of the data, not the content of what metrics are in there, meaning what they're testing. So yes, the metrics need to be specific to the industry, but the conformed dimension sits above that layer and describes how do I define the metrics. So, but it's been a slow journey. People haven't quite picked up on the conformed dimensions because it's so conceptual. So that's why I wrote the book. It's coming out in July, and it's kind of stupid proof. I mean, it's just kind of like very, very simple. So I think people, when they read the book, they're going to be like, "Oh, this is too simple." But the problem is bridging. Like what Dale's talking about is he needs, and I really appreciate that he has 12 metrics or probes, he calls them, and then multiple metrics as well. That's kind of the conformed dimension should provide that baseline, and then your organization needs to modify that to fit your organization. And I think Dale is probably going to get people coming to him now and saying, "Come and do it for me," and in legal management, specific to my context, right? So I'm a legal department. I'm managing the costs of my legal services that I purchase to protect my IP. So yeah, you're right, Dale. I think they complement each other.
Well, yeah, because I think the conformed dimensions, and I'm probably showing my ignorance here, I think the conformed dimensions goes a long way to help you establish what that baseline should be. Okay.
Yeah.
Whereas Midcot starts monitoring from that, and it gives us a methodology to monitor. Are we, because in a statistical process control, you have to have your baseline.
Yeah.
Right. And your target. And so, again, I'm not an expert in conformed dimensions. I did research it somewhat when I was developing what I'm working on, but I thought that was still that shortfall, that gap, is it tells you, a static point, but it doesn't help you as you move forward in a dynamic system.
Well, I think the time series aspect of it is there, but it doesn't say anything about the AI nature of things. Like there's no aspect. That was not even in my head at the time, right? So and I don't claim to have that aspect. What I do see as a challenge in the industry right now, and we need to collaborate with each other, is the unstructured, and I think this is one of John Talbert's call to action to other professionals is, let's create unstructured data quality rules, unstructured data quality dimensions and metrics. And I see a lot of overlap there between structured and unstructured. So like logical consistency, logical consistency means in the conformed mesh means measures whether two attributes of related data are conceptually in agreement, even though they don't record the same characteristic of a fact. So, the way that I typically use this is like, meters versus feet. Do they conceptually agree with each other? Is one, if you converted it, would you get the same concept coming out? And I think that there's a lot of that in the unstructured world that we could still use.
Now, when you mention the unstructured world, I'll make a caveat here. On all my research in this model, I built it around textual data. I have not explored using it to video or audio.
Yeah.
I mean, when I was doing my dissertation, they all keep saying, narrow your focus, narrow your focus, narrow your focus. And this is about as narrow as I could get it to illustrate what I'm going. But, we all see it like a video or any type of image. When you try to create an image using ChatGPT or Gemini or whatever, I don't care. You always get these errors because it's going to either garble up your text, or you might have overlapping, the picture's got some kind of flaws in it, or in video the same way. So I think the accuracy in the image and video area is much greater than it is in the text generative models. From audio, there's a great deal of potential in either one of them, but there's not enough people focusing on how do we apply this type of framework to that to help us improve it. I mean, there's a lot of work. If I have the opportunity to present some of the others, what you're going to find, this is basically is opening up a new area of research on AI or large language model research. There's a whole new field of research on how do we quantify and measure, monitor, mitigate model governance. Because what you can't measure, you can't manage. What you can't manage, you can't govern.
Then just to confirm my understanding, is a lot of the probes that you're doing, or where you're probing, is the incoming data. You're not probing the output of the large language model. You're probing what's coming into the data, what's being added to the data, right? And that's
with Midcot,
checking,
that's correct.
And this is the important point. ST left and she asked the same question, is where is the measurement happening? Is it happening in observing the responses of the LLM, the chat GPT, or is it of the data coming in and the retraining? So you are focusing on any data that gets added to it. And I think what your model is saying is that after a while, you got to start from the beginning, because as you keep on compounding and adding, it's not going to get better. And I think this is sort of what the biases tell us for structured data. If we overtrain, then it just gets worse and worse. The area starts to deteriorate. I don't think structured data or data elements where the model just collapses and there's nothing you can do. I think that's a big difference that ChatGPT or LLMs have to deal with. It's that absolute collapse, and so now you've got no bent. You can't fix it in any way. You've got to start again.
Okay, so this brings up a good point. As you notice, I have different components here. Today we talk primarily about the Midcot.
Yeah.
But there's no one point in this data lifecycle that you can focus on and you're going to fix anything. I mean, you can improve it, but whoops, back up. Get back to my chart here. There we go. So these different components measure different aspects of that whole data lifecycle. Midcot deals with the training corpus. The SimPrompt Plus is I developed a new methodology for prompting. It's a semi-coded prompting that helps improve the data quality of your output and checks it. Your BME metric suite, or the basic metrics, apply across these 4 different areas. The BAAGF, the bias, misinformation, error, architectural governance layer, that focuses primarily on the architectural aspect, and it measures how much contribution does the architectural design impact the BME propagation and amplification. And then you've got your governance output. So this is your data corpus, this is your architects, this is your user interface, and this is our governance. So today we just focused on that one, and you're correct. That's all it focuses on, is that aspect of the model.
Okay.
Did I answer your question?
Yes, you did. You did.
Hey, Dale, I have a question I had asked before in the chat. Is this, how does the size of the model impact these aspects that you mentioned about this? I'm talking about the deterioration of the model over time. If the model is very large, does it mean it has a slower rate of decline as opposed to a smaller model? And it's a leading question. It's a leading question because I think the implication is that, like, when you develop a small model at a company, your corpus is a lot smaller than like Claude and Gemini, the big LLMs. So does that mean that the models are going to go bad like super fast? What do you think?
To be honest, I don't know. That'd be an interesting aspect to measure. My inclination would be if you've got a smaller model, 2 things are going to happen. If it's smaller and you trained it on your training data, and you've got good data architects and data analysts that preparing that corpus, and you apply this model that I created, you're probably going to be able to maintain the integrity and the data quality of that model much easier because it's smaller to manage, and it's narrower in its scope of data. But then when you get to the larger, you're starting trying to include everything in the universe. Now you've got to have to deal with context windows, and you got 3 different layers of context windows. And so the context windows, I think the training corpus, if it's the entire, I'm going to go to the other extreme, entire universe of data, you would think that it's going to kind of balance itself out at some point. You know, you get enough data, like when you're doing your Six Sigma curve, and you've got, you know, the volume of data kind of normalizes the data. But context windows play a big, huge part in that, because you may have this mountain of data sitting out there, but the context window, when you write that prompt and it's trying to respond, is taking a bucket over there, you know, like one of these little kids with a little bucket and a little shovel that they use on the beach. You're going out there and getting little pieces of it at a time. And depending on how you structured that prompt and the context that you gave it, it may or may not return a proper response. For example, if I ask it, what's the top 10 movies of all time? That's all I ask it. It's going to go out and it's going to look at all the movies ever made, and it's going to make its own assumptions of what I meant about the best movies, and it's going to give me a list of 10 movies. Well, that may or may not be the best movies, depending on how you define it. Am I making sense? So, and that's what a lot of people are doing, is that they're not aware of these context windows. And when they're trying to query the system, they're not getting access to that full set of data. The context windows narrow that response. And if the context that you built into the prompt or before the prompt, and how you write the prompt. And that's why I developed SimPrompt Plus, because when I was doing my research, I was trying to mitigate some of this user cognitive bias so that I could test the models back upstream, how much impact that was having without me contaminating it with my own bias and the way I write the prompt. Does that make sense? So
Absolutely.
to go back to your question, I think the smaller the training corpus is, the more specific we're going to be when we're querying it, because it's related to my company or business, whatever I'm doing, and it's going to be easier to manage. When you got the larger, it becomes more complex on how you're going to manage that data corpus.
Unfortunately, I semi disagree with you. Maybe just the devil's advocate in me. I disagree with you on the fact that we assume that it's going to be higher quality because we actually manage it. Because most companies don't have really strong. I mean, let's just be honest.
Yeah.
Most companies don't have really strong data architecture, data governance, metadata management. And that's what they're finding with the AI programs. They start throwing their AI at the data or the data at the AI, and it's not bringing back what they would expect. But that's okay. We love that in the data management community because it's driving value to us. Finally, we're getting the love that we so much deserve.
Yeah.
Hopefully.
And I agree with you. And you know, when you're trying to do it from an analysis from my, you know, I go to one extreme to the other, and I make these assumptions. It's either good or it's bad.
Well, you have to. No, yeah, you can't make any conclusions about some
I
assumptions.
agree with you 100%.
I think it's fair.
But Dan, isn't the point that Dale is bringing in here is when you go wide, then you've got lots and lots of variation. Okay, so that wide scope is you know part of the challenge in terms of neutralizing the data, in terms of neutralizing the view. But even if you've got some inherent quality problems with your own environment, you've really got a culture of what's actually happening. And so you can continue training by adding new code, and it doesn't get to a point where it just collapses.
Well,
because you haven't
I don't
got
know.
that.
Yeah, I don't know. I see good things on both sides, right? So the nice thing about the large model is that I have massive variation, which should reduce bias. In theory, the bigger the pool, you should reduce bias because there's more opinions in the marketplace. The problem is that if you know, so I don't know how soon. So Dale had pointed out that my own research then published into the public, then I self-consume it and I become a carnivore. But I don't know how quickly that happens because like Conformed Dimensions, right, has been around for 10 years, but it hasn't taken off. So if I did research with AI on Conformed Dimensions, I wouldn't be a carnivore because it's just not that public. I think there's certain things, you know, it's like music, right? Those artists that hit the top 10 or whatever it is, there's not that many artists that hit the top 10, right? So yes, if you're researching those top 10 artists in music, you're going to get that corruption and that sort of carnivorous cycle. But for the other topical areas, I don't know that we're going to have that problem. I don't know. Like Dale said, I don't always have all the answers.
I mean, there's so many, you know, the opening slide that I have, I created this, and you notice the person's opening the doors. You got all this information around here, but all of a sudden you open the doors, and it's this wide world of data out there. And that's what I experienced when I started digging into this, you know, going down the rabbit hole on the AI governance and developing these frameworks, is that the dynamics of this whole process, that whole data governance life cycle, is so vast, if you will. It's kind of like trying to herd cats. So the best, you know, what I've got now, you know, a caveat, this is an early stage of this model development, gives us a stick in the ground to start working from. But I think, again, this is a whole new area of research and development to take this further.
Great. Let me see, Dan. Anything more from your side? Any other questions?
I guess to your previous question, Howard, like small versus large, I think what most companies are going to end up doing is using the external models like Claude and whatever as their baseline, and then they'll use their own corpus for sort of like to make a smaller contextual window. And
Yes.
so they'll grab everything from their local corpus, and then they'll grab the baseline and use the functionality, the linguistic capabilities, natural language capabilities of the LLM in conjunction with each other, right? So you have the
Yes.
best of both worlds. My concern is with the little one, I mean, with the local one is, let's say that I have a legal law firm that's doing, analysis of legal work contracts. Let's just say contracts. So I have a pool of 10,000 contracts that I've written over the years, and my model is built on those. And there may be the size and the importance to my business may be focused on a simple 50, and the model may always keep pointing people back to those 50 when in reality what you're trying to research is outside those 50. And so I think that the microscopic, I mean the small nature of your local corpus drives too much almost deterministic behavior instead of probabilistic. And so that's why you need the larger model to continue to have that probabilistic rather than always driving back to the same examples. Dale, what do you think about that?
Well, again, there's a lot of different dynamics, and one of the metrics that I developed is called the architectural hallucination risk score. Okay, and that's part of the architecture that you can have the best training corpora in the world, but depending on how it's processed down through the model, it's going to affect the output. Okay. When you mentioned that, I may start out with a language model, a small language model, instead of a large language model, that's trained on my training corpus, but through an API, I link it to Claude or Genesis, whatever, okay, to help drive that process. The quality of those models is going to affect how your model works, because each one of them has a different strength and weakness. I've got a list of over 300 different AI models that are out there, and they all have different strengths and weaknesses. And when I started researching that, you started looking at the context windows, for example, how much they can process. One strength is here and weakness over here, then you get the next model is this. So what the architectural hallucination risk score does, it uses a probe to feature mapping, works backwards, because Claude's not going to tell you how they design a model, neither is Gemini or anybody else. But if you understand the key weights inside that model, you can almost mitigate some of it by the selection of the model, number one, but number two, how you design your interface, you can mitigate some of that. So this gives us a way to work backwards. It's almost like reverse engineering to see what does that model look like, whether I'm using Claude or whoever else. It literally gives you a picture, and it's not 100% accurate, but it's pretty darn close.
And I think, Howard, that's where we're going is different. I think as we move along, Lambda is focusing on X and the Microsoft model on Y. I think that's actually kind of where we're at. Isn't that like back in school when you're in grade school? Tommy's a fast runner and Susie's good at drawing and Jack is good at whatever. I think that's where we're seeing right now with the players, the big players, is everyone's trying to figure out what they're known for and then specialize in that.
Yeah, and I think a lot of them are being able to say, okay, we give you access to all of the models and you choose which one to go to depending on the task that you're doing to get the right output. So there's that it's almost gone to another level in terms of, okay, I've got a standardized API, and depending on the call, depending on what I'm trying to understand, I go to the right model. And that's, I think, if you have an understanding from what Dale is saying, now I know which one is the right one to go to. Now, the other thing, Dan, if we talk a little bit about the RAG and to an extent, what the RAG's trying to do is trying to ensure that when I do present a prompt to an LLM, I'm giving it the right context and not allowing it to have too many alternatives or too many assumptions that it draws from to be able to give you the answer. So it's a little bit like what Dale said is, if I say, give me the top 10 movies of all time, well, what is my top 10? There's context that's missing. So the idea is to use your data inside to ensure that the context has been well defined before you start asking interpretation of it.
That's a very good point. And I haven't articulated that very well in my work, but that's very significant.
What's the question? I'm not sure what's the question though, Howard.
No. So where I think we're missing some of the value of working with our data, and it's like small or large or whatever it is. What we need to do is to make sure that when we as an organization are issuing a prompt or trying to get a better insight from Claude or whatever it is, we want to ensure that the context on which we're asking reduces the hallucination from the LLM that's coming back. All right, so
go ahead.
Yeah, that's, I mean, all we're trying to do
yeah.
The more context we give it, the better the window is, or the better the description, and that's only context to us. It's not context to any of our competitors. This is our context.
Yeah, so that's why I think like what you're talking about is like query rewrite and contextual appending, like so.
Yes.
So you know how with ChatGPT, how it got so much better when they started saving your prior answers, right? So
Correct.
like when it had context to the kinds of things you want to hear about. I think that went off on the deep end when it came to relationship stuff. They, like people were, I don't know, there's some scary stories about people falling into relationships with ChatGPT because it was sort of like, building up like, I remember when you said that my eyes were beautiful or something. But it's really important though that that we use the RAG for, like you're saying, triangulating on what specifically they want, right? Narrowing the field, right? So that's the purpose, right? Is the vector sort of database where you're trying to narrow the field of what you're trying to seek. And I actually, the biggest problem that I see locally is that we keep trying to deploy enterprise AI models that solve like a lot of people's problems or domain specific problems, but we haven't trained people on what AI can do more broadly, because the more that they learn just how to use, whatever my favorite tool is in my day-to-day life, like you learn how to write, how to write your queries better, right? Your prompt refinement.
Yeah.
As you sort of learn to do that in your private life, I think people start bringing it to work, and they get better at developing, whether or not it's a formal markdown file that says these are the things that I care about. So any question I ask you, take these sort of like important values into context. Or if it's more broad and just saying, in the department of X, research Y. I think that's where we need a lot more facilitation. But maybe that's just what I see. I don't know.
Yeah. Now, in what you're talking about, Dan, if I look at the insurance industry and some of the work I've been doing in terms of medical claims, when they talk about claims and episodes of care, they are constantly looking at, well, what terms have you used in this claim that you brought about, and how does that contradict with the episodes of care that we've been managing? Okay, so it tries to find fraudulent behavior because you're using terms incorrectly and you've raised them on your claim requirement, but you're not using the correct set, and now they can discover where you are pushing the boundaries.
So this is kind of where I kind of take exception to the way a lot of organizations deploy AI. Everybody wants to go to these AI agents or agentic AI. But what they don't understand is that models cannot make value judgments. They're algorithms. Okay.
Yeah.
They can't think and reason. They don't make value judgments. So I'm an advocate. What I argue for is AI augmentation, not full AI automation, because you can't get a reliable model of anything unless you got that human in the loop to make that value judgment. Even my models, I build in the Midcot. It's not AI driven, but because that purpose of the human in the loop. Okay, so people tend to look at, I say they use AI like a tool, I mean a toy instead of a tool. It has its limitations and capabilities. Leverage that in how you design your architecture and your deployment, so that you do an AI augmentation to help you. So as you're saying, Howard, where you're building on your training corpora that you built in, part of the model says, all right, here's the data that's there. We use that for context. Then it helps drive some other inquiry. But it's not taking that and doing it all on its own. The human is guiding that.
Agreed. I mean, it really comes down to it's just exceeding the boundaries. And as soon as it does that, I can either, if it's in the boundaries, then we can go for auto approval. If it's outside, I've got to get a human in the loop to explain why there's these levels of anomaly. Great. Dale, thank you very much. Dan, I also appreciate the discussion. I'm sure we could talk about these things.